divide today's session into two halves. The first half will be taught by Shifpreet. He will be walking you through the algorithm that we are supposed to be using and the maths behind all of it. So you will be understanding the basic concept for machine learning. For this part, I would recommend that you guys keep like a copy or something handy because you'll be given some. You'll have to do a little bit of maths to fully understand this. And in the second half, I'll be walking you through the code where we will actually be coding using all of the knowledge that you have gained so far, and we will be building your model. So yeah, Shiv, are you there?
Yeah. Uh,
Okay, great.
so
So
hi
let's start.
guys, can you hear me?
You're not
So
audible,
how are you
please.
guys? Are you ready for maths? Hello guys. No, no maths. Uh, so if you will get any problem in the between, just interrupt and ask. Okay? So the total ML is basically machine learning can be divided into two halves. Like there are two types of machine learning. One is a supervised learning and another one is unsupervised. So what's the difference? Like, if you guess by the name, then what do you mean by supervised or unsupervised? So any data set, it depends on the data set we use. So any data set can have two types of data sets. One is a labeled data set. So here we will use a labeled data set, and in unsupervised we'll use a not labeled or unlabeled data set. So what do you mean by labeling? So every data set, let's say there is a data set of different type of cats. So the in the label data set, each cat like there is a data set of animals, and there are, let's say, two cats, three dogs, and all. And it will be written there that this guy is a cat. It is labeled. But in an unlabeled data set, there is no labeling. So the machine cannot figure out that what it is, and that's why we will need unsupervised machine learning there. But we'll not dive into unsupervised here. It's a different concept. We will be doing supervised. So in supervised, there are two kinds of sorry. In supervised, there are two things we do. We do regression or we do classification. So in regression, basically the output is a continuous data. Let's say the data will lie anywhere on this line. It's not that I can say it can lie here, 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 here. It can lie anywhere in the line. That's why it's a continuous data set. And in classification, it is a discrete data set. So my spellings are trash. I don't remember DIS. Yeah. It's discrete. It means that there is a set of data. Let's say the output can be 1, 2, 3, dot, dot, dot. It can't be like, it's not a range, it's numbers. Like, it's, let's say there is cats and dogs, then it will say cat, dog, like that. It will not range from cat to dog. It's just a single number data set. Did you guys get it? So
Yeah.
we will be
Wait
dealing
again.
with, huh? Which one?
Explain it again.
Classification.
Yeah, yeah.
So classification means the data set will be discrete. It means that you will have the graph will be something like this. Let's say here, 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 and here, here, and here. So any point will be on this. Let's say here, here, here. Any point will be like discrete. How will I explain discrete? One second. So basically there are single numbers. It will not be ranging. So let's say in a regression, we'll say that the data or the output can be from 1 to 10, any number. It can be 5.5, 5.6, 6.9, anything. In discrete, it can be only 1, 2, 3, 4, dot, 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 10, only integers. It can't be 5.5 or 5.6 if it is not in the set of output.
So basically, you are saying that in regression, the data set is have a range, like
No, the
from
output has a range.
okay, the output has the range, and in
Yeah,
classification, it's just the element those are present in the data set,
yeah,
right?
yeah. Let's say we have to distinguish between, let's say, a spam email or a cat and dog photo classification. So let's say you are given a folder with cats and dogs. You can say that this is a cat, this is a dog, this is this. Okay. But in, let's say, a regression, an example can be a house prediction model. So you can't say that this house is exactly 10 lakhs. You will say it is from 10 lakh to 15 lakh. That is a range. But in the cat dog thing, you can say that this is a cat and this is a dog. So it has only two outputs, cat or a dog.
Yeah,
There
so
is
it'll
no in
never be like a hybrid between a cat or a dog. It won't be like, हाँ ये cat भी है, dog भी है, or like something in between. वैसा नहीं होगा. You'll have labels. You'll have categories. Like it either falls under category A or it falls under category B. Does that make sense?
Yes.
Okay.
Okay.
So we will not even be doing classification today. We'll be doing regression and a specific type of regression. Yeah. Specific type of regression known as linear regression. Okay. So what do you mean by linear regression? What do you mean by the term linear? Sorry for that.
Straight line.
Yeah, you can say a straight line, a parabola, anything that has one variable is called a linear. Okay, but we will be again doing with a straight line, as you said. We will be doing, let's say, y equal to mx plus c. That that is what we'll be dealing with. So let's say we are given a data set with, and we will uh, so in the data we have a x value, we have a y value. So let's say we have 1,000, 2,000, 3,000, dot, dot, dot. And in Y, let's say we have 400, 500, 600. It's something, okay? So if we plot this, something like this will come. Just imagine us plotting a scatter plot, like yesterday. Okay, there is a set and we are plotting a scatter plot. So now our aim is to draw a line such that it fits. It's the best fit for the graph. Means this distance, this error will be the least. When we predict something, it will be perfect. So this line is called a line of regression, and that is the aim of the linear regression, to find that line of regression using machine learning, using the algorithm we wrote. So the predictions, how the predictions work is, let's say this is x and this is y. We will give an input of x, and it will, let's say the x is somewhere here. So it will predict what value of y here it is. That is our output. Did you get this? That this is kind of important. So we have to get this part.
Can you repeat it once more?
Okay. So let's say you have a graph, and these are the points of the graph, and we will our aim is drawing a line. Okay, this is our aim, such that it will be the best fit for that graph. The best fit means, like any prediction we do, it is very close to the original value. So this error, this we'll call the error, We'll discuss it later, but this error should be minimal. That is our aim. In short, that is the whole aim, and for any value of x we put in, the respective y on the line is our prediction. Did you get it?
Yeah, yeah, got it. Thank you.
Got it? Okay. So that is the whole point of linear regression. And what we will do is first consider a hypothesis, something as a hypothesis. So our hypothesis is just a guess. Hypothesis just means a guess. And now I'll explain how we are gonna do this ML model thing. We always have a training data, right? This training data will be passed through a learning algorithm. And this learning algorithm will then create a hypothesis. So this hypothesis is our guess for the prediction. So this is a function. It's an equation which tells us that for a specific value of x, what is y. It is a function. Sum x with y. If we give the value of x, we'll get the value of y. And y is our prediction. And if we give an input here. So this is the whole process of a linear regression model or any machine learning model. Okay. So now we'll move on to what is a hypothesis in the case of linear regression. In linear regression, we'll have a straight line. So the equation of a straight line is y equal to mx plus c. So this y equal to mx plus c can be in our codes. We will write, not codes, in our equations we'll write h theta of x equal to theta naught plus theta 1 x. So this is what we'll be using in our all the functions we derive after this.
How did you get this equation?
So these are just, so this theta 1 is same as m, this theta naught is c. We just exchange values, and these are just random values we'll start with when we are coding. Don't think about the codes right now. Just think about a hypothetical situation where we have a line of y equal to mx plus c, which is written in the form of h theta x equal to theta naught plus theta 1 x. Okay. So this is the hypothesis, and we guess it that our uh, model will be a linear model. So we will guess that this is our equation. If this is our equation, we will then calculate a cost function, cost slash loss function. So this cost slash loss function, if you remember, I told that we will be getting a line which has the least error. So this is the error, and for this is the error, for this is the error. So this error is, nothing but, let's say e, this error is nothing but y of I minus h theta of I. So this value is y, okay, for some index. So I means some index. This is the 0th y, this is the first y, this is the second y. So this I signifies which y are we talking about. It's just any y, and the error will be, so this part is from the hypothesis h theta equal to theta 1 x plus theta naught. So this h theta to y minus h theta. Do you get how I calculated the error?
Could you repeat? Explain it again,
Yes.
please.
Yeah, okay. So let's say this is our line of regression. This is the point on the line, like this is the point on the line which our model will predict. And here is the actual value where in the data set. In the data set, this is the value. In the model, this is what we predicted. So the distance between them is the error.
Yes.
So if the distance between them is the error, this is y of I, because this is from the data set xy, and for some index, let's say 0 1 2 I, for some index I, value of y is yi, so we took it yi. And for the same index I, our model will predict h theta of I, and if we subtract it, we will get the error, and we'll take a mod so that error is always positive. Did you get it, or should I go again?
Yeah, got it.
Got it.
Got it? Okay. So moving on. Now we have our error. And what is our main aim? To decrease the error. If our error is the least, we'll get the most accurate values. So we have to just decrease the error. So now even if I write h theta of I minus y of I is the error, and we need to write a cost function. Let's say the cost function, I will represent it as a theta naught comma theta 1. So the cost function is a function of theta naught and theta 1. So we have to decrease the cost function. So if I decrease the square of the error, it will also decrease the e. Let's say if the 2 square is 4 and I decrease the 4 to, let's say, 1, this also decreases to 1, right? So if I decrease the square, the actual number also decreases. Does it make sense?
Yes.
Yeah, so we will take the square of the function. Have you ever heard of square mean square? Like there is a root mean square and there is a mean square. So we'll take a mean square. So if we take a mean square, it's the summation of every element. Let's say 0 to m. There are m elements, and for average we divide it between m. The mean will be 1 by m. The square will be h theta of I minus y of I plus square. So this, and for easier differentiation, I will just multiply a 2. If I decrease this function, will it also decrease the error?
Yes.
So
Yes,
this
it
is,
will.
yeah, so this is our aim, that this is our cost function which we got from our mathematics. Now we will use something known as a gradient descent.
What
There
is
are a lot.
M there? M.
M is the number of elements we are training the data on.
Okay. Okay.
Okay? In the data set, there are m number of elements, and we will sum all the squares of the element and divide it by 2m, and try to decrease that.
Got it.
Okay, minus yi plus square by 2m. That is our cost function. We got our cost function.
Y
If
to
you
M,
want to write,
Y to M, divided to M.
2m. So we divided m to get the mean. Okay, so to get each function, it's just like average. You are taking all the summation of the functions and dividing it by number of functions. Let's say you have 5, 7, 9. What you do? 5 plus average will be 5 plus 7 plus 9 by 3, like the number of elements. So that's why we are adding everything and dividing by m. And this 2 is just so that if we differentiate it, we'll get an easier value and we can work with that value easily. Because if we decrease this function, it will also decrease the error. So we can multiply and divide any constant we want. Doesn't matter.
Okay, thank you.
Okay. So now we'll go to something known as a gradient function. Can you? Okay, I'm not. Let's say we go to Google and uh, gradient descent. If we go to images and let's say this image, we go to this image. So our cost function is a complex function. It will give you some graph like this. Don't get intimidated by this graph. It is just a graph and we don't have to draw it. We just have to visualize it. Let's say you're on top of a mountain and you you are blindfolded and you have to come down. So what will you do? Let's say you are left on top of this, okay, and you have to come down to this or this. How will you come down? And you are blindfolded, you can't see.
But just keep walking. I'm going downwards. And
Exactly. Every
I,
time you take a step, if you feel like you're going down, then you are in the right direction. If you go up, then you will change your direction and try some other direction. Right? Did everybody get what I mean?
yes.
Yes.
Yeah. So now there will be a point where every time we try to go any direction, we'll be going up. And that is our minima. Okay, so that point we have to find using our ML algorithm. So we will find the gradient descent. So for a gradient descent, the idea is you start with a random theta naught and theta 1. It's basically the M and C value. We start with a random C value. While coding, the computer will decide a random value. No, we don't have to decide the random value, it's okay. The second is we try to decrease the cost function. So that is the whole idea of gradient descent. So remember in 12th, whenever you had to find the minima, what did you do?
Differentiate and equal to 0.
Yeah, exactly what we have to do. We have to differentiate it and then put it equal to 0. So our j of theta naught and theta 1, it is a function of two variables. So we have to differentiate it two times, but like differently. First we'll partially differentiate it with theta naught, and second time we'll partially differentiate it with theta 1. Okay. So
Can you repeat the second line that you've written?
this one or this one?
Yeah, yeah, the second one.
Yeah, we try to decrease the cost
Okay,
function.
cool. Thank you.
Yeah. My handwriting is bad. Sorry for that. So, what we do, our cost function was this summation e by d theta naught. I will just write it in a new one. Nobody can understand that. What I equal to 1 by 2m summation of d by d theta naught of theta naught plus theta 1x. I just replaced the hypothesis with what it was, right? And minus y of I, and we'll be squaring this. So, guys, can you differentiate this with respect to theta or not and tell me the value, the output?
What is the h theta?
Uh, so this thing is h theta. The value of h theta is theta naught plus theta 1x. I just substituted it. I should have written it.
Okay, got it.
Yeah. So this is our maths bit. Tell me the answer. I give you 3 minutes because that's all we got. You have to just differentiate with respect to theta naught.
Hmm, 2 theta plus 2 theta 1 x minus 2 y1
2 theta.
plus 2 theta 1 x
Mm-hmm.
minus 2 y I.
Yeah.
2
So I can write this,
y.
right? By 2. I can write this and summation.
Hmm.
So it's basically 1 by m summation of theta naught plus theta 1x minus yl. This is also xi. So for each index we are calculating, so xi. So you this is just the by solving the equation we got this. So this will be one of our equations that is very important while coding. We have to, like, we will be coding this thing in our if you don't get the differentiation part, you may remember this, but how it came is more important. Okay, so the next we'll differentiate is j of theta naught comma theta 1 with respect to theta 1, because we need to decrease both theta naught and theta 1 to get the minimum value. So it will be 1 by 2m summation, not 2 times summation, x, sorry, theta naught plus theta 1x of I minus y of I plus square. Yeah, you yeah, differentiate it and tell me with respect to theta 1.
One by m summation theta naught plus theta 1 x minus yi whole multiplied with x.
Yeah, correct. So that is what we'll get after differentiating this. So this is also important. This will be using in our code. So now what we planned first, we will differentiate this with respect to thetas and put it equal to 0. Okay, if we put it equal to 0 and I multiply alpha both sides, there will be no difference. I'll tell you what alpha is. It is called a step function. It is also called a hyperparameter, and this thing is also random. By experience you will get what you have to put, but for linear regression models it's always 0.01 or 0.0001. Jayant will tell you while coding that bit. So, and I'll tell you what the significance of that in a bit. So if you multiply this, it's the same thing, because both side if you multiply it's 0. And then if we say theta j, so this theta j means j belongs to 0 comma 1. So it can be theta 0 equal to theta 0 minus alpha. So I can also multiply a minus, doesn't matter, and add theta j both sides. J, d by d theta of j. Did you get this? What I meant, what I mean here. So I can also write like theta 0 equal to theta 0 minus alpha d by d theta of j. So this is our gradient descent function, which will be decreasing our theta 0, and theta 1 equal to theta 1 minus alpha del by del theta 1 of j, which will be decreasing theta 1. Did you get it?
Yes.
Okay. Now the last bit, which is what is alpha. So alpha is a step function. Okay, alpha is a step function. Now, what is a step function? Now, let us go back to the mountain you were climbing down from. Let's say you are here. So, the time you take to come here from here, how and what does it depend on the most?
Gradient.
Inclination. Oh, sorry. Depression. Angle of depression.
Not the angle. Like, let's say the depression is constant. Like, you are always, let's say there are three scenarios, and you are always coming down from the same mountain, but the time you take is different. So, what does that time depend on?
The slope.
Not the slope. It depends on the
Mass.
The
length of the
length of the
slope.
steps.
What?
The length of the steps we take.
Exactly. So that is step function. If you take two small, like very, very small steps, it will take you an eternity to come down. So this alpha value which you will be guessing should not be so small that you will come like it will take a very long time and you have to run the loop so many times that the time complexity will be very high and your program will break. That is not how small this value should be. And it should not be so huge. Let's say you're here, then you took such a big step that you came here, and then you took some step that is here. You miss the minima. You will think the minima is here, the minima is here. And we need the smallest possible value to get the most accurate model. So the theta value should not be so high that you will jump over the minima, should not be so small that it will take you an eternity to come down here. It should be a decent step which you will get by, let's say, analyzing the model, training the model for many times and getting the exact value. That will be guesswork because the world is random. There is a lot of guesswork which we do in ML. Okay, so we one second. Yeah, guys, sorry for the interruption. Yeah, so that is step function. Did you get step function? This is the last topic for the maths bit. So this alpha here represents how, like in how small steps do you want to decrease the value of the theta. The theta will be C or M. Should I explain it again? I guess I think. I will take it that you guys understood. If anyone has any doubt until this point, you can ask any doubt in
Can you
any
explain
question.
the alpha part again, like this
Yeah,
equation,
okay.
step function? No, not this one.
Here.
From here. From the
So
step
how
function.
from here I got this, right?
Yeah.
Okay, I will explain it. So we got our J, uh, sorry, where is eraser? I'll find eraser on there. Yeah, del by del theta of J theta 1 and theta 2. So here theta is basically 2 times theta, sorry, it's basically 2 times theta 0 and theta 1. So I'll just represent it as theta so that we don't have to write two equations. So this was the idea. The whole
Yeah.
idea was we decrease the function and put it equal to 0. So if we
Hmm.
multiply alpha both sides, will it make any difference?
No.
Yeah, exactly. This, and if we add if we add theta of j, like for the C we will be doing theta 0 and for the M we'll be doing theta 1. So if I do theta j equal to theta j and I multiply a minus here and minus here, it is still 0. So theta j minus alpha into del by del theta. Yeah. So that is how I got this one. It's the same thing as this, just multiplied and added both sides, which doesn't make any difference.
Okay.
We still have the minimum. And why I do this is I I decrease the cost function. Yes. Did I get the value of theta naught and theta 1 by decreasing cost function? No. I need those values. These values are what will be going in the hypothesis, that is the prediction. So these values will put here and get this, right? So we have to decrease this. So to decrease this, I wrote it something like this. Theta 0 equal to theta 0 minus alpha del by del theta 0 of j. So this will be decreasing a theta 0 and we'll getting the minimum value of theta 0. And similarly, we'll be getting the minimum value of theta 1 by doing this. Did you get this?
Yeah.
Yeah. Yes, Arish? Uh, yeah. So that's it for the maths bit. There is one other bit which I want to tell you is any model can be of, like, you train a model. Let's say you trained a model which has a data set of, let's say, like this, and you trained a linear regression model which will go like this, but you wanted a model which should go like this. It went like this, right? So any predictions we do, let's say here, will be a very bad prediction. The actual value is somewhere above and we are predicting a very bad value. So it is called underfitting.
There will be less error, na?
Error will be high, accuracy will be less. So like, let's say you plot a graph, let's say like this. The points are like this. So if you predict, let's say, something, and there is some point here, and your model will predict for this value of, why isn't my stylus working? Come on, work. Guys, one second. Nice. Stylus doesn't work.
Try exiting tab mode.
Okay.
And
Yeah, okay. So let's say our for some x we want a prediction, and this prediction falls down here, and our model will predict something, let's say 10, and the actual value in the test data is, let's say, 100. So our accuracy is gone. There is nothing. Your model is predicting a complete wrong stuff. So this is called a underfitting line, where your test data gives a very bad result, and the training data, like if you put the training data and what you get, that also gives a very bad accuracy, very high error. So, and the other case which we don't want is, let's say there are some points like this, and your model did something like this. So if my model did something like this in our training data, our accuracy is 100%. Wow, yes, we achieved the world. But on test data, the, let's say, the accuracy is 75%. That is bad. All our predictions should, accuracy should be on the test data. It should be depending on the test data. The test data should give a good accuracy, because that is what the real world will test it for. So that is called a overfitting then. So we don't do, you should train your model such that the training the error in the training data should be close to the error in the test data. It shouldn't be the training data is very good and the test data accuracy is very bad, or both of them bad. We don't want both conditions. So you should take your hyperparameters like the alpha values such that it will give you a good line and not a overfitting or underfitting line. That's all the bit for me. If you have any doubts in the maths or any part of the theory bits, you can ask, or else Jayant will be taking on. Could you repeat overfitting? Okay. So let's say your let me make a better one. Let's say these crosses are your training data. So the data set, the set is divided into 80% train and 20% test. Let's say the training data, for the training data, you got a graph. So at the end, your model will give you a theta value, and like at the end, you will be creating a graph, and everything works with graphs here. So let's see your ML model predicted something like this. This is the graph your ML model predicted. And if you take a random x, it will predict on this line. Let's say on our test data, our, I will represent it with a knot. Our points are something like this. So accuracy of our training data. So any prediction we do on our training data, it will be 100% accuracy, or let's say 99% accuracy. That is very good. But when you use the same model to make test data and test that data, you put the input of the test data and get a prediction, and the accuracy you get is 50%, because like the line is here, your thing is here, and it will predict how much wrong it is predicting. It will take that and calculate an error, and that error is very bad. But your training data is giving you uh, a very good accuracy. The test data is not giving you a very good accuracy. So if that is the case, it is called a overfitting. It is very good for your training data, but it is very bad for your test data. So when you choose your hyperparameters, just keep in mind that you don't have to train it so much. Like you train the model so much that it will perform excellent in training data, but fail in your test data. So you have to choose your alphas, and there is another variable named step that will be that Janti will tell you while coding. You have to choose those data such that you don't overfit or underfit your model. Could you get it? Yeah. Okay. Other than that, any issues in the maths bit or theory bit, or else Janti take it over. And Jamboard files has been shared in the group, I guess. In the chat, you can download it, and I recommend making notes because ये याद नहीं रहने वाला. ठीक है.
Yeah,
Janti,
and
take it over.
thanks.
Bye bye.
Hi. Please share it again. Oh, yeah. Second. Okay. Do you guys want to get into the coding right away, or do you want like a 2-minute breather?
2 minute breather.
2-minute breather. Okay. Anything. Okay, hi, you guys ready? Hello.
Yes.
Okay, great. Let me share my screen. So like it'll be preferable if you guys just take out your Jupyter and code it with me, or if you want to maybe like. So what's basically going to happen at this stage is we're going to start coding our model, okay? And you will be expected to give us like make that same model with the same data set and submit it to us via Google form, which we will share towards the end of this workshop. You will have until Tuesday 8 p.m. to give it to us. And if you give it, like if you submit it and it's correct, we will, iNeuron will be sending you guys a certificate. Again. So whether you want to code it with me right now as I go, or you want to maybe look at it right now and then later on code it yourself, it's up to you. Okay. Good. So can you guys?
Excuse me,
Yeah.
this meeting is also recorded, right? Like the previous one?
Yeah, this one is recorded and this will be going up on YouTube.
Okay, thanks.
Uh, yeah. And the codes are on GitHub, so you can always refer to them. Okay, so here's basically what happens. Whenever you start making an ML model, you get a lot of data. So you start first, you divide that data into training and test data. We will be doing that in the ratio of 80/20. Okay, and that's usually the standard ratio you would use. For certain cases, maybe you would drop it to 75/25, stuff like that. What about either the adjustment you might do, but generally it'll be like an 80/20 ratio. Then, once we're done with that, what we'll do is we will convert that data into NumPy arrays or matrices so that we can work with it more easily. And then we will try to create our line of regression using all the formulas Shift taught us. Okay, so I have the Jamboard open on the side because just in case I forget what the formula is, which is a huge possibility. I suck at maths. Convert into what? Convert what into what? Oh, so uh, when you get a data set, you'll just get one huge data set, right? So you cannot, if you use the whole of it for just training your model, you will have no way of knowing how accurate your model is, right? So what you would do is you would divide it into two parts: training data set and test data set. Training will be 80% of your data set, which you will be feeding into your hypothesis or your algorithm, so that the algorithm can figure out ki, acha, where is your line of regression, or like what is the slope and everything. And your test data set is basically you will take the value of x from your test data set, find the predicted value of y, find the actual value of y that is existing in your test data set, which is the rest of the 20%, and figure out ki, how much error you are getting between the predicted and the actual value. And that way you will know how good a model you have coded. Okay. So for any model, like the first thing you need to do is get your imports. Okay, so can you guys tell me what are all the models I will probably need to import?
Pandas.
NumPy, pandas, matplotlib.
Okay, great. Import number. Matlab. Okay. Yeah, that should do for now, I think. So the next thing we want to do is probably read our data. So that is something we did yesterday. Again, remember, wherever you have
Use
your
math.
file, you will want. Sorry,
Want to use maths? Like want we import maths?
maths.
We won't be needing maths in the like calculation because there
Uh,
is no root over square can be calculated without the maths. So no maths in
Oh,
that.
okay, fine.
okay, so Yeah, when we do this, yeah, so the next thing we will want to do is we will want to read into our data set. So the first thing you need to remember is wherever you are making your file, you will want your data set available within that same directory. If you have it in a different directory, you will have to give the whole path. So for now, my data,
Can you share the data set?
it's the same data set that we used yesterday. It should be available on
Okay.
the WhatsApp group. Yeah. So we do data set equal to pd dot read CSV because ours is a CSV data set. That's CSV. Okay, so there is a command in pandas which lets you drop null values. So for you, we have cleaned the data set, so you do not have any null values present in that data set, right? You guys know what a null value is, no?
Yeah, I guess empty.
Yeah, exactly. So like that data set does not have any empty values, but like if you ever feel like your data set might have a few values that are empty and they don't really have a value happening, what you can just do is you could do data equal to data dot drop na. Okay, and that will drop all the empty values for you. Okay, we run that, and then we do data dot sorry ed dot data frame, and we look at our data. So this is our humidity versus temperature. So for this linear regression graph, we will be plotting our x value is going to be the humidity, that is our input, also known as the feature. Okay, so any input that you give is known as the input feature, and your temperature is known as the output. Okay, so our aim today is we will give humidity as the input, we want temperature as our output. Okay? Simple as that. So let's divide our data set, which I taught you guys how to do that yesterday. So first of all, our training data is 80% of the length of this. Wait, sorry, I don't think this will be len x. Yeah, and that should give you 239 rows. That is your training data. Uh, within the same bit, let's try to get our test data extracted as well. We will not be using this right away. We'll probably be using this in a bit. Yeah, this will be used towards the end of our model when we start doing accuracy check. For now, we'll just be working with our training data. Okay, so any questions in data extraction?
Can you please scroll up?
Yeah.
Yes. Okay.
Sorry?
Okay, no issue.
No issues. Okay. So, yeah. Uh, once you're done with this, now we have our test data in data train variable. Oh, yeah, what we did is like we started from 80% of the like we started from after 80% of the rows. So we started from row 240 and we went all the way to the end of the data set. Here we started from 0 and we went till 80% of the data set. So this goes 0 to 239 and this goes 240 to 300, like 299. Make sense? Okay. Now we just want our values of x and y. So our x is equal to numpy. We make a numpy array. So np dot array data train dot what is our x, like what is the parameter we are trying to store in x?
Humidity.
Humidity, exactly. So we put humidity here, and our y parameter is temperature, so we do the same thing. Data train dot temperature. Okay, And that will give us our x and y. I'll just print it out for now. You don't really need to. But yeah, do you see, like, you get two arrays. One is your x array and one is your y array. Okay. Next bit. So the first thing you want to do is you want to make a scatter plot of your data, right? So an easy way to do that is to maybe just create a function that will do it for you instead of like doing it over and over again. So in Python, how do you make a function is you just write def and you write the name of your function. And inside, you give them whatever parameters you want to pass. Okay. Like here it will be called arguments, right? So in here we do plt.plot. We want to plot x comma y and we want to give it a scatter plot. Okay. Once we do that, we can run it and we can just call that function for our x and y. And that's what your graph will look like. So this is just your x plotted against your y. Make sense?
Yes.
Okay. Just for convenience, we can also add like an x label and a y label. So you could either pass it as a parameter here or you can just hard code it, whichever you want to. It's obviously preferable to pass as a parameter, but I'm just going to hard code it for now because we're not going to be changing this data set. So our x is humidity. If I can spell it, and y label is temperature. And I forgot plt dot. Yeah. Huh? Oh, makes sense. Yeah, there you go. X label, Y label. So that's your graph. Now, now that we've done the graph, let's start coding our hypothesis. So the first thing you want to do to code your hypothesis is we want to start with some random value of theta naught and theta 0, right? Sorry, theta naught and theta 1. So what we do is let's set theta equal to a numpy array and we'll give it random values. So for that, we'll use the function random.rand and we'll make sure those values are always between 2, 1. Now, the issue with doing just this is that every time you run the program, the random values within theta could change. And you don't want that. You want, like, every time I run the program, that random value should stay the same. So to do that, you can just do np.random.seed. And let's see 2. Okay. Okay. Now we can define our hypothesis. So what was our hypothesis function? Do you guys remember?
Theta 0 plus theta 1 into x.
Yeah, exactly. Okay. So let's just return that directly. We do theta 0 plus theta 1 into x. And because we're using x and theta, let's pass x and theta into the function. Does this make sense? Any questions in this, sir? Okay, I'm going to assume not. So the next thing we want to do is we want to plot the line of regression. Okay, so let's define our function def line, and we're going to pass our theta into this as well. So the thing is, we want to plot a line of regression, but we want to plot it on this graph itself. We don't want it to like be a different graph. So what we can do is we can set the axes equal to plt.gca. What this basically does is it will get the axes from the already existing graph. Okay. Then we set our x value equal to np.array, sorry, access dot get xlim. Okay. I'll just write out the code and then you guys can, I'll walk you through it. Value and theta. And we plt.plot the rest. Okay. So can you guys give think if I said GCA gets the current axis of the graph that is existing, what do you think axis.getlim does? Any ideas?
Limit of x-axis.
Yeah, it'll get the x-axis, exactly. So it'll just take this x-axis and it'll start to plot it on that. So our x values has been set to this same axis. Our y value is equal to the hypothesis using these x values and the value of theta. So that is just this thing, okay? And we are plotting a dotted line. So let's run that. Okay. Let's define one last function that draws both of these together. I'm just going to copy the code for that one because it's basically one function called draw, which will call both these functions, the plot function, which we defined up here, and the line function, which we defined here. Okay. Once you do that, we run it and we do draw, draw x, comma y, comma theta. And that should give you the line of regression. So this is the line of regression which we will initially obtain. What do you think is wrong with it?
Are there too many errors?
Exactly. Too much error. You can already see that these points are far up ahead as compared to where this line is. So the error will be very high. What we want to do is we want to train this line to come something like this. And this is where we will apply our gradient descent formulas. When we do that, it will basically give us the reduced value of theta naught and theta 1, which will then actually fit into our model and give us the right amount of error, like a decent amount of error. You can never reduce the error to 0, but still we can get somewhere closer than whatever this is, right? So the first thing we should do is probably define our cost function. So I'm going to take the length into a variable called m, do m len x, and let's define our cost function. So that should take the arguments x, y, and theta. Return. Okay. Tell me how this goes. Like which formula are we looking for here?
The j of theta 1, theta 2 is called the
Yeah. So, okay, I think I'll just go back to the Jamboard and show you guys. Yeah, this. We basically want this formula, j theta naught theta 1, this formula, we want to code it. Okay. So we want to do 1 by 2m. Okay. Let's do that first. 1 by okay, no. 1 divided by 2 into m. Okay. Then,
The by in between 1 and bracket.
sorry, 1 by 2 into m. And then we want to multiply this into the sum of the mod of the error, or the square of the error. Okay. So how do we take summation for numpy arrays? We just do np.sum. Okay. Now, what is the error difference situation? You can just do high you can do the value of the y, like the predicted y, which will be our hypothesis, is x comma theta, right? We want to do that, and we want to minus y values from that. Okay. And we want to raise this whole thing to the power of 2. A double star means raised to the power. Does this formula make sense? Hello?
Yes.
Yeah, works. Okay. So that is your cost function, or j. Okay, once you're done with that, let's just call our cost function one time so that we know what is the current value of cost when we are starting off. So x comma y comma theta. That is our current value. Okay, and now we want to find a minima. So the thing is, if you saw the gradient descent graph, there are probably going to be multiple minimas. Now I can't go around looking for the lowest point. That will drive my model crazy. So what we do instead is we start decreasing our model and we look for a point of convergence. So at some point you will reach a certain minima where no matter how low you go, the difference keeps being like extremely small, right? Like maybe 0.001 का difference आ रहा है, 0.001 का difference आ रहा है. At some point, that difference which is coming will start becoming irrelevant, and that will be a point of convergence. So once you reach that point, you start running. You stop running your model, because otherwise, if you just go on a hunch and you're like, I will find the absolute minimum, uh, you might never reach it. Okay, so let's actually code the gradient descent function now. I'm gonna name this gradient descent. It'll accept x, y, theta, alpha, and the number of steps. Okay, so x is your x values, y is your y values, theta is the current value of theta that we have, alpha is a hyperparameter, right? So that is how much you are going to be reducing it by in every step. And steps is just how many steps are you going to keep running this program for, right? So when you say I want to run this program for these many number of steps, what do you think we'll be implementing here? What? A loop, right?
Yes.
Yes. So let's make a loop. It's called a for loop. We do for I in range steps. So let's keep calculating our cost. Okay, so like our old cost will probably be equal to cost function x comma y comma theta. Okay, then we update our value of theta naught and theta 1. So let's make two random variables. Temp 0 is our first one, and temp 1 is our second one. Okay, this is when we come to these two formulas. Wait a second. These two, which we spent so much time deriving, how we will be reducing theta naught and theta 1 ka values. So you'd basically go like temp naught is basically theta naught minus alpha into Okay, can you guys tell me what the differentiation of this was? Differentiation of the cos function with respect to theta naught.
One upon m
Okay. So we go by
summation of theta naught plus theta 1 x.
summation of theta naught and theta 1 x, which is basically our hypothesis, right?
Yeah.
So yeah, our hypothesis. Sorry.
Minus y.
Hypothesis. Exactly.
Mhm.
Minus theta x comma theta minus y. Okay. So that is your differentiation of the cost function. In the next one, we want to do this. We want to do something similar, but now with theta 1. So let's do that into alpha into
1 upon m.
oh sorry, you need a summation. I forgot.
Oh,
Yeah.
yeah.
Yeah. Okay. 1 upon m.
Wait a minute. Why did you have two summation on? Okay. Got it.
Jay, we don't need
No,
two
no, no. We don't need
submissions.
two summations.
You are already
Yeah, yeah,
summing
yeah,
it.
yeah,
It's
yeah.
Yeah.
okay if you don't.
Yeah.
Yeah. Okay.
Okay, so I can get rid of this one because 1 by m to constant है ठीक है हाँ चलो okay.
Then वही hypothesis, summation of hypothesis.
Okay, and we want that into x, right?
Yeah.
So we will want a dot product. So let's do np dot dot. Let's take out hypothesis x comma theta minus y into well, not into, here we are doing dot, so dot into x. There we go. Wait, did I do this right? No, I didn't. Okay. यहाँ पे आएगा comma x.
जय पहले ठीक था शायद.
नहीं ये डॉट का पैरामीटर है ना x. So
एग्जैक्टली
this
तो
is
डॉट के ब्रैकेट के अंदर है.
हाँ ठीक है sorry. Okay, there we go. So np dot dot. This is your j function and this is your into x. Okay. And then we just replace our theta naught and theta 1. So no, actually no, sorry. Theta naught comma theta 1 is equal to temp naught comma temp. Okay, so that's just a simple variable exchange. The values will exchange. And we will want to get a new cost. What is our cost after changing the value of theta? X comma
I
y.
think while you are changing it, it should be only 0, right? While you're keeping it in brackets, like temp 1.
Sorry. Yeah, my bad. Variable name is temp0. Okay. So this is pretty much going to do the entirety of our calculation, but we would want a way to look at whether our calculation is going in the right way or not, and if we want to change some parameters on something. So what we basically want to be checking is, when we do new cost, is the new cost less than the old cost, and if we are in fact decreasing the cost or if it is increasing. So we just run a simple if else statement. So if new cost less than old cost, print decreasing, and let's print the value of new cost. Okay. Else we just print increase. And I'll do that in caps so it's easier to see if we actually do get an increase. Okay. So any issue with this particular function? Do you understand what's happening in here? Okay, so I'm just going to run the gradient descent. Gradient descent. You run it on x, comma, y, comma, theta. Let's mention our alpha equal to something, and we will mention our steps equal to something. So these values, they will obviously depend on how the training is going. You can modify them to get better accuracy, etc. But yeah, as let's for now, when we're starting, let's try with 0.01 and we'll run it for maybe 100 steps. Okay. And at the end of it, I will want to print, I will want to print the value of theta. Okay. So when you run it for 100 steps, you see we get this value of theta, but it is still a pretty considerable decrease. You haven't like gone too far down, right? We haven't really reached a convergence, just 3 point at the similar value kind of a situation, right? So we can probably run it one more time. We will have to reinitialize theta. Give me a second. Yeah, from here. Oh yeah. Yeah, so now we're getting somewhere closer to the actual point of convergence. Okay, so if you want, you can run it one, like you can add another zero and try to run it, or do like an alpha one more. But yeah, I think this should give us a good enough result. I'll just run it for one more zero. Give it a sec. Okay, see now you've clearly reached a convergence. Itne sare 1300% for sure that you have reached a convergence, and that is your final value of theta. Okay, so again, you guys should probably take these two values, mess around with them, see how much more accurate you can get. And the easiest way to tell how accurate you've gotten is to just call your draw function once again, right? And see what it looks like now. So you see the line has actually come very close to the best fitting line, right? We went from something that looked like this to now something that's looking like this. Would you say this is a best fit line?
Yes.
Guys, yes or no?
Approximately equals to best fit line. We can say that it is the best fit line.
I
Yeah.
mean, after looking this graph, it looks kind of best. I don't know how much best we can go.
Yeah, so like it looks pretty close, right? So once you feel like okay, I'm getting somewhere, I think this is one of the good, like one of the best fitting lines. I'm not saying this is the perfect one. You can think about actually start calculating your test, calculate this model on your test and see how it's looking there, how it's performing in terms of accuracy. So for that, I'm just going to define two numpy arrays using our test data, which we initialized somewhere towards the beginning of our code. And we just take data test or humidity in test x and data test or temperature in test y. Okay, let's run that. And let's define an error function. So I have one predefined for us. Okay, so basically what this is taking is it's taking the value of test x, test y, and theta. Okay, then it's giving you a prediction value of y, which is the hypothesis, right? And it is returning the error, which is absolute, return absolute. I think ABS is why, no, ABS works without maths. Okay, let's see. Yeah. So that And to print the error, we just run a simple error ka ye. So, okay. Test x text. Okay, that should do. So basically, m is taking len of test x, which is this array. S is equal to 0 for I in range of the m. We're doing error, which is calculating this sign for every value of test x. Okay, we run that, and it's giving us an error of 4.6, which means it's plus minus 4.6 degrees on our test data set. Now, a different way, if you want to visualize how good your model is doing, is you could probably just call the draw function, but instead of running it on your training data, you can run it on your test data. Right? So you will this. And yeah, so even on our test data, that is a pretty good fitting line. It could probably be better, but yeah, this will do. Yeah. But no matter how much better we make it, it'll probably just decrease by 0.2 or 0.3 more. But this is a pretty good fitting line overall. So, any doubts?
Well, at first there was a x that was being initialized for length of the data in the data set, the CSV. I'm trying to
Mm-hmm.
do that code, but it's saying that x is not defined. So I'm kind of facing a problem there. If I just
Uh, Wait a second, I'll just go up there. Like over here.
For that, change the X to data.
like we went for like data.ilog
Oh,
80.
there. Okay, yeah. I think there was some error in that particular bit of code. It should be len data and not len x, because
Okay,
we
I
hadn't
did that
defined.
too, but
Huh.
it's showing some warning like pandas doesn't allow columns to be created a new
Yes, yes,
activity.
ignore the warnings.
Okay, fine.
As
There's no
long,
Warnings
that's
yeah.
are
just
meant to be
warning.
Well,
ignored.
it shows the 240 rows into two columns, but it also shows a warning.
That's okay. Python loves giving you warnings. It's okay. As long as it works.
It's just like the warning. You ignore the warning.
Okay, so that is your first ML model. The code is available on the GitHub, and you will be expected to submit this. You can submit it as a PDF or just as a standard IP by NB file, like Jupyter will give you. Okay, and depending on your submission, you will receive certificates. So overall, I would say the workshop is concluded. If you have any doubts, you can tell us right now.
Can you scroll up?
Okay, to like here.
Mode up.
Yeah.
Yeah, yeah.
Uh,
The code you wrote right now will it be there on GitHub for reference?
Yes, yes, it is there on GitHub for reference. The link has
Will-
been shared. Yeah.
yeah, I put it on here.
Can you
I
share it
checked the
on the
code.
WhatsApp group, please?
Yeah, I will put it in the description.
Yeah, yeah, please. And when will be getting this record on YouTube?
So on the YouTube, I think somebody is recording, so we'll try to upload it by tonight or tomorrow morning max. Okay. And you have till Tuesday 8 p.m. to get us your submissions, and those recordings will be available for as long as our channel exists.
And like the form, I will provide it in the group, WhatsApp
What's up?
group itself. By tonight, we'll provide that. And other than that, one small bit. So basically, the gradient descent is like the beginner guide. It's the ABCD for machine learning. You're just touching the surface. It's nowhere in the depth. It was just a 2 day process. So this is how much we could teach you. So if you want to learn more about it, you can try a module named sklearn. So sklearn is basically coders have written this the same programs and piled it up for the best possible output. There are many modules in it, so you can see which one works. So we usually use
Can we submit
policy.
using this?
No, you
No,
have to submit using gradient design in that way. So for
this.
anyone who wants to learn more and continue the journey, so for supervised learning, unsupervised, there are many models. You can go up YouTube. You can. There are many other methods like you can use statistics for finding the minimum value, and all. Other than that, after you do this, you can hop onto neural networks and PyTorch and TensorFlow. So
Yeah.
that is the journey that you have to traverse your own or find some stuff.
So, like, if you guys ever want to like connect and learn with us or something, since this should probably one of the last work, and this is the last ML workshop for now. We're not very sure about the future opportunities we'll get. वो तो देखा जाएगा. But if you want to keep connected with us, you can always join our Discord server. And whenever you want to like discuss about anything or you want to learn about anything, we can just all join VC and talk, screen
Tag
share
us
and go
and
through
we'll be
it.
here.
Yeah.
You
But
can summon us.
yeah, so that's great. And yeah, that's pretty much it. So for all official purposes, the I will say that we are done with the workshop.
Yay.
Huh.
Yeah. So, what
Random
is in
dot
the random
seed.
seed?
Okay, so basically when exactly, let me share screen again. So basically, जब when we try to initialize the value of theta. So right now, the first time I run my program, my np.random.rand will give me a random value between 2 to 1 and it will give me an array. Now, the second or third time I run this program, after I change maybe the parameters or something, I will still want कि जो theta का जो starting value I had picked, whatever random value it was, it is still that same random value. So for that, we will do np.random.seed so that even though it is a random value, that random value doesn't keep changing with how many times you run the program. Okay.
Yeah, how to see the accuracy?
The accuracy is like this is what we've written as a basic way of testing the accuracy. Otherwise, like if this is too confusing or complex for you, you can just get the you can go into the scikit-learn ka ye, and you can just get their accuracy calculator and use that, right? Shiv, do you know the syntax for that?
One sec. I think I have it. One second. Let me check.
But otherwise, here what we have written is what we basically done is test data ka humidity and temperature we've converted into numpy arrays x and y. Then we've defined a function called error, which accepts this test x and test y and theta as the arguments. So we've calculated the prediction value of y using our hypothesis function. And then we've just done test y minus prediction. So like actual value minus predicted value. We returned that. Then we ran a loop which runs for the length of text x, and we just added up the errors, right? So that will give us the total error, and the average error is total error divided by the number of readings.
Okay, so I got the error calculation for this. I think I should share my screen and
Yeah, yeah, yeah.
people can see. Which one is this? Localhost. Yeah. Oh, nice. I sharing the wrong one. Yeah. Guys, can you see it? So this is the same data set using sklearn. So I used SGD regressor if you want to use and try it for yourself. So this is the accuracy, how you calculate accuracy from and the error using sklearn methods. It's just matrices dot mean absolute error. So there are three kinds of error. One is the mean absolute error, which we calculated. There is a root mean square and a mean square error. So you can use any of these, and it's like 4.4. We got 4.6 by manually doing it. So this is how you do using sklearn. So if you run the same one which we did for more times, it will the error can go up to like 4.02, but then it is point zero some changes, so it's okay. You can play around with the values and maybe try it 1 million times running the program and do that shit. So
Yeah,
it'll
we
be
have to change
fun.
the values.
Yeah.
Yeah. Yeah. Okay. So
Yeah. So that's it. That's how you do it with sklearn. And
okay.
any other doubts?
So I have a question. I don't know it's relevant or not, but what was the motive of this model behind, like, why we are doing this? I mean, to just check the error accuracy.
So
It's
this.
for prediction. Like you gave a data set, you got the output, and like you gives in let's say humidity and temperature. You gave a humidity, you get a temperature. Similarly, you see the weather forecast on a laptop. It uses similar model, not of course gradient descent. It's very beginner, but it uses somewhat similar. It's just the basics. You put let's say today is 10% humidity, then what is the temperature for today? So that is what we predict. That was the motive of this model.
So basically, when you look at weather prediction, you will be looking at various different factors. You will be looking at the cloudiness, how the tropics, the climate, the humidity, all of that, right? You'll be looking at a lot of factors. One of those factors will be humidity. So here we only consider that one factor and we try to predict. So we try to predict temperature on the basis of just that one factor. So when you talk about weather stations, like Shiv said, you would probably be looking at a stack of such linear regression models, or some that is like that would be implemented in the form of something called a neural network, right? So that is not something we will be covering under the scope of this workshop. But yeah, a neural network is basically just a much more complex form of regression models. And it's basically like if you stack a bunch of regression models and the output that you get, that is kind of what neural networks will do. So by doing this model, we kind of got you the taste of what the basics of machine learning look like. And now that if you've got your concepts clear, once you start going into the more advanced and complicated stuff and making more complex models, you'll have a much easier time understanding ki chal kya raha hai, right?
Okay, got the gist of everything.
All right. So if there are no other questions, then that's it. The on official terms, the session is concluded. If you guys just want to interact about something random or talk about college or something, you can do that, I guess. Or if you want to know more about Crazy Codigo or iNeuron, let us know. Otherwise, you can just leave the meet. It's cool.
Everybody is in the WhatsApp group, right? There is no one who is not in the WhatsApp group. Or else I'll just give the link again because all the forms and everything will be posted there.
What is this crazy Codigo, like? Who started this and all?
So, like, me and a friend of mine called Agnesha, her and I started this around June 2021. Okay, and it was just supposed to be a YouTube channel we post because we do a lot of dumb stuff when we code. and it slowly grew up to be a lot more than that. So now we've got Shiv and we've got other people. We've got Sam, and we've got a whole Discord server and people talking about tech and discussing coding problems. And we basically just want, like, it's a community for coders to discuss their problems and discuss, like, and just discuss what progress they've made on what codes and grow together.
So how do you get contact with like companies like iNeuron and all?
I
Like,
think for that one, Shivam can answer you better.
You just
Uh,
find internships and other communities and tie them up. That's how you get
sh-
contact.
See, a magician never reveals their secrets, okay?
quite simple,
Okay.
right? Just add 1 + 1 and that's it. It happens.
Yeah.
Okay, okay.
Shivam, are
Do
you
you
in the
guys
meeting?
offer any internship or something?
No, we do not have any
No no,
internships. We
वो गलती से निकल गया भाई, भूल जाओ, मैंने कुछ नहीं बोला. देखो ये जो 40 लोग है, देखो ये सब भूल जाओ, ऐसा कुछ हुआ नहीं है. हम यहाँ है नहीं. मैं मरने वाला
We're
हूँ.
we're a
Sorry.
community of just colleges and students and coders. So like we don't offer internship opportunities, but like
But
if you
you have
join,
links with companies, right? Like,
Yeah,
not exactly, but yeah,
yeah,
this is
you
like
have. Like,
I
you
know
can
that.
deny, but you have, right? You make these kind of workshops with certificates who are like
I this is
connected
our
with companies.
first one. This is our
Yeah, yeah.
first one.
See, the thing is, it may be your first one, but I'm pretty sure it's not the last.
No,
I'm
we
right.
really hope not. We
Yeah.
really want to do more.
So you know the way to connect with companies and have these workshops and all. So you know the path somewhere,
Bro, it was
somewhere.
lucky. It
It's a
was
luck.
luck.
It was complete luck.
It was machine learning modeling in real life. We don't talk about this. You can contact us in personal DMs and we will may or may not tell you all the things.
See,
You
if you're
guys are
not
in
going to
fourth year,
tell me,
right?
then what's the point of contact? But still,
ऐसा दोस्त बने ना भाई, ये क्या है, काम होने दे, ठीक है, ये
okay,
क्या
okay,
है.
okay. I will be making a good friendship with you, but not now. But we'll see.
Okay, okay.
Sus.
Yeah, yeah. We have your contact numbers, right? It's in the
Yes.
mail, right? You have sent.
By the way, Somyajit, weren't you on B12?
No. I was in B22.
Okay.
You guys
My
are in
bad.
fourth year, right?
No.
No.
Third year,
Second.
No.
second
Third
year.
semester. Third
Yeah.
semester they are in.
We're in second year.
Nice.
Great. I am your senior, right? I am in third year.
Oh,
I'm
hi.
learning from you.
Same. I'm in third year as well. And I'm learning
Hell
from you.
yeah.
You guys are doing really great. Like, we are learning from you. So please continue what you are doing.
Thanks. You can, of course, again, I said join our Discord server and be part of the
Promotion.
community.
Yeah.
Second years are not in
Yeah.
campus yet, right?
No, we will be arrive. I
आएंगे
will be
आएंगे
arrive.
17 तारीख आएंगे ये
हाँ,
सब.
मैं 13 को आ रही.
तेरा
हाँ,
तेरा.
तुम आओ, तुम 13 को आओ, उसका कुछ नहीं, बट या
Yeah.
फिर मिलेंगे, फिर तुम कितना सीक्रेट छुपाते हो देख लेते हैं.
अच्छा.
We need police protection.
Bro, इसीलिए लाइब्रेरी नहीं खोली थी हमारे लिए लास्ट सेमेस्टर.
Makes sense.
कोई बात नहीं. आओ तो सही, कुछ सीक्रेट नहीं बचेगा.
लाइब्रेरी में पढ़ाई ऐसे भी नहीं होती.
फिर पढ़ाई करने
हमें
जाता
पता नहीं होगा.